why amount not make difference in see, yes, amount is changing. Yes, I'm talking about the amount only, amount to the ions only, not the metal electrodes. See, C1, C2. This amount in the solution, that is different here. That makes a difference. But the metal amount, you can see they are going to cancel out. Whatever is the whatever the thickness of the silver, that is not going to make any difference here. They are getting cancelled. They are not involved in the E0 cell. Moreover, you can see, yes, now appropriate answer I'm not giving you, mathematical answer I'm giving you. You know this equation, E cell is equal to E0 cell minus 0.0591 upon n logarithm of concentration of the product upon concentration of the reactant here, right? Concentration means basically ion concentration, not the metal solid concentration, not the solid metal amount. That is why E cell value depends only upon the concentration of the ions, but not on the concentration of the solid metal amount. Yes, now I think very clear. Okay. Okay. See this. I can say C2 upon C1 here. C2 upon C1. Yes, no. Let me know if you find any doubt here. So it means the concentration of the cathode must be greater than that of the anode. Then only cell will be working, otherwise it will not be working. Am I clear? Right. Now, I'm not discussing about the second type of electrode concentration cell. See, I'm making a diagram here that will make the more concept clear here. Here I have HCl. Here you have HCl, hydrochloric acid. And here is a SHE. Is a platinum wire, and I'm passing here a hydrogen at a P1 pressure. Another in the same beaker, I am passing hydrogen gas at a P2 pressure and now connecting them. You can see here the potential difference, when the pressure difference is there. Pressure is different here. And now the cell will be showing concentration difference. You can see that HCl is same here, metal is same here, hydrogen is same here, but only the gas amount is different pressure. Right? Getting me? So you can see that hydrogen is changing into H positive ion in the here at a P1 pressure, double bar, and the H positive ion is changing into H2 at a P2 pressure. You got it? How I converted this presentation into the cell presentation here? Yes, Yash, Neha. Okay, once more. See, I say the H2 gas at a P1 undergoing oxidation to give H positive ion in the HCl here. And the H positive ions are converting into H2. It means here the reduction is going on and here the oxidation is going on. Here it is undergoing oxidation and here it is undergoing reduction. Here, hydrogen is undergoing oxidation, so I say H2 is converting into H positive. And here, H positive is converting into H2 at a P2 pressure. So oxidation half reaction and this is reduction half reaction. Is this clear? Right. Now, wait. Here I told you that H2 gas at a P1 pressure is changing into H positive ion and the H positive ion is changing into H2 at a P2 pressure. Is this clear? That's what I am writing here like this. So I can say at anode, this H2 at a P1 pressure is changing into H positive ion with the loss of electron here. And now at cathode, gaining electron becoming H2. Electron cancelled. Getting me? H positive cancelled. P1, this is the P2. Converting into H2 at a P2. Yes, let me know. Any doubt till now? No doubt. Good. Neha. Good. For this, I'm writing E cell is equal to E naught cell minus 0.0591 upon n logarithm of P2 upon P1. P2 upon P1. Right? E cell value is 0 because both are hydrogen here. Minus 0.0591 upon n logarithm of P2 upon P1 is equal to E cell. So E cell is equal to, make it positive here, 0.0591 upon n logarithm of P1 upon P2. For a cell to be working, that P1 must come out to be equal to P2, then only the E cell will come out to be positive. Yes, which two cells? The previous one and this one? Yes? Okay. In the previous case, we were considering only the concentration. And here we are considering the pressure in terms of the pressure. That's it. In the previous case, it was the concentration. And in this case, it is the pressure. Hopefully, I'm very clear now. Okay, Anirudh. I'll repeat here. You can see that hydrogen is undergoing oxidation here. This to this. And this is the reduction part. Till this point, I think it's clear. Anirudh? Right. And for this equation, I'm writing the Nernst equation. P2 upon P1. So E cell, E naught cell minus 0.0591 upon n logarithm of P2 upon P1. To make this negative value into positive, I had done it P1 upon P2. That's it. Change here. And this should come out to be positive. For that, the P1 must be greater than P2. Then only the E cell will be coming out to be positive. Okay, good. So just go through this one. I have already told you. Explained, already explained. This is clear. Okay. Let us solve this question. Uh, is it yes, Rija? P1 greater than P2. Yeah. So just solve that question. It will come out to P1 upon P1 greater than P2 only. Now, write equation for the half reaction. First part. It will be good if you solve with me. Means please keep your books and notebook and pen with you. So you can see the zinc is undergoing oxidation here and it is undergoing reduction here, right? So at anode. Yes, students, please let me know what should I write here. At anode, what will happen? Oxidation of zinc and converting it to zinc 2 positive, right? Its concentration is now 0.15 molar. And now at cathode, zinc 2 positive ion gaining electron here to becoming zinc. It's a 1 molar here, right? So this is the oxidation half reaction. This is the reduction half reaction. Zinc and zinc cancel, electron cancel. And zinc 2 positive 1 molar changing to zinc 2 positive 0.15 molar. Yes, Anirudh, what I was saying here, at anode also it will also gain electron. No, Anirudh. At anode it is always the oxidation. Oxidation means gain of the loss of electron, right? Zinc is converting into zinc 2 positive ion. It means zinc is converting into zinc 2 positive with the loss of 2 electrons, right? So the first part is clear. Second part, calculate the EMF as the cell discharges. Does the difference in concentration become smaller or bigger? Let us see. We calculate here E cell is equal to E naught cell minus 0.0591 upon n logarithm of product upon reactant. So E cell is equal to, this value is 0 minus 0.0591 upon n value is equal to 2 logarithm of 0.15 upon 1. Am I clear? Yes, students, am I clear? Right. So E cell is equal to 0.0591 upon 2 logarithm of 1 upon 0.15. And now last part calculation you can do. Yes, friends, can you do the last part? Right. Any doubt? Yes, any doubt here? What is the use? Means I'm not getting your question. What is the use? What is the use? Application of the, okay, application of the concentration cell. Practically, it is not any such use, but it has been made possible theoretically only that even if the concentration metals are same, the cell can work on the difference on the basis of difference of concentration. Right? Yes. Okay. Now, next part of this topic is what are the application of relationship between delta G and delta E naught cell now. Delta G and E naught cell. This is our topic now. Finding E naught for the half reaction. Number one application is finding E naught for the half reaction. Right. See, reduction potential of ferric is given to you. Reduction potential of ferrous is given to you, and you have to find the value of this equation, ferric to ferrous. So what you have to do is 1 minus 2 is equal to E naught of the 3 will give. Let me know if you find any doubt here. These two values are given to you. The reduction potential of these two equations are given to you. Ferric to iron and ferrous to iron. And we have to find out the reduction potential of the third equation. That is ferric to the ferrous ion. So can I say it is 3 is equal to 1 minus 2? Yes or no? Yes. So now this E naught cell value, I can say we have give the free energy change delta G3 is equal to G1 minus G2. So 3 is equal to minus NFE naught cell. We know that delta G is equal to NFE naught cell, right? So Fe3 into 3 Fe1 minus 2. N is the 1 here, N is equal to 3 here, N is equal to 2 here. Delta G is equal to minus NFE cell. Right? Any doubt here? Yes, yes. What I'm saying is, I say delta G is equal to minus NFE cell. In place of the N here for the third equation, N is equal to 1 here. In the second equation, N is equal to 2 here, N is equal to 3 here. So writing here, E3 is equal to 3 E01 minus 3 E2. Now it is clear. E1 minus E2, G1 minus G2, G1 minus G2. Just like this, 1 minus 2. 3 is equal to 2, 1 minus 2. See, I can say 3 is equal to 1 minus 2. Right? See here. If I just subtract these two, I can get this equation. Yes or no, Yash? Okay. Now, okay. Good. So delta G is equal to 3 E1 minus 3 2 E2. Now this is clear. Right. So I'm giving you this equation now, based upon the previous what I have discussed here. See, what is given to us is Thallic 3 positive plus 2 electron to give Tl positive. And for this, the E naught value is given to us. That is equal to 1.26 volt. Second is Tl positive, gaining 1 electron and becoming Tl. Its value is already given to us, minus 0.336. And what we have to do is, we have to get the value of the thallic ion plus 3 electron to give Tl. This value to be determined. Yes or no? Getting me? Yes, are you getting me? Okay. Now tell me, how can I do this one? This is the equation number 1, this is the equation number 2, this is the equation number 3. So how can I get the 3? How can I get the 3? 1 minus 2. 1 minus 2, right? So don't do it directly. 1 plus 2 here, right? 1 plus 2. So delta G3 is equal to G1 plus G2. Or I can say it is equal to 3 E naught minus 2 Fe naught plus Fe2. So E3 is equal to 2E1 plus E2 upon 3. Yes, students, let me know. Yes, students, getting me? So you have to see that which equations are to be added or subtracted. In the previous case, see there, in the previous case, we had to subtract this value, 1 minus 2 to get this value. Here in this equation, we have to add 1 and 2 so that I can get the required equation. Yeah. See, what is our equation here? We have to get this equation. It means these 3 electrons to be added now. 2 electron plus 1 electron, 3 electron. Thallic ion, this and this is cancelled now. That is equal to thallic ion. It means I'm getting equation about 1 and 2 added here. If I add the equation 1 and 2 only, I can get a third equation. That is my required equation. Yes, Yash. Now delta G is equal to minus NFE naught cell. Remaining is all our calculation here, right? I hope everybody is clear. Neha, are you clear? Anirudh? Some of my sleeping students also, they're not taking part. And now, second application is K equilibrium using electrode potential. K equilibrium. See, we are given here silver reduction potential. We are given silver chloride reduction potential, and you have to find this value. So this equation number 2 minus 1, I'll get the equation number 3. Check whether I can get it or not. I want to get the equation number 3. So 2 minus 1, you get the equation number 3. So minus Fe naught cell minus Fe1 is equal to 2.303 logarithm of Kc. delta G, you know this value. So A2 minus A1 is equal to logarithm of Kc, equilibrium of, that's what we have to calculate now. Getting me? Yes, any doubt here? Last equation. Say, up to this point it's clear. I think yes, up to this point it is clear. Yes. So what I had done is I had divided the whole equation by the f value. So A2 minus A1 is equal to 2.303 RT upon f, logarithm of K. So A2 minus E1 is equal to 0.0591 logarithm of K. So this is A naught cell value is equal to, that's it. Now let me know. Everyone is clear? Right. Now find the equilibrium constant for this reaction. You can do. Yes. Okay. I'll do. See this. Cadmium gaining 2 electron becoming cadmium. The reduction potential of this is given to us. Second is reduction potential of this is given to us. It means gaining 2 electron becoming cadmium and 4 ammonia. And cadmium ion plus 4 ammonia to give this value to be determined. Right? These two equations are given to us. Yes, students, are you getting me? These two equations are given to us. So this, to get this value, I can subtract the second from the first, then I can get the third equation. I am subtracting the second from the first. Right? So E naught cell value is clear now. And now we know that E naught cell value is equal to 0.0591 upon n logarithm of K equilibrium. This is the K equilibrium here. That's it. Very simple. Getting me now? Anirudh, Neha, right. Now we come to the next topic here, that is what are electrolytic cell. Till now we have discussed about the electrochemical cell, right? Okay, briefly, you let me know what is electrochemical cell. Just in one line, everyone, please write here what is electrochemical cell. Very good, Yash. Chemical energy into electrical energy. The device which convert the chemical energy into electrical energy is a electrochemical cell. And now we are going the reverse way. Very important. Now we will provide the electrical energy to the chemical, and some chemical will be produced. Some chemical energy will be produced. So electrical energy into to chemical energy. Previously we were getting the electrical energy from the chemicals, and now we will pass the current into the chemical. Right? Getting me? Now, see here, very important here. I am passing here. See this diagram here. Here we have sodium chloride and I'm passing current. Right? So this sodium chloride dissociates into Na positive and Ca negative. In the electrolytic cell, anode is positive and cathode is negative. So at anode, which ion will be attracted? Chloride ion will be attracted? Yes. And there, it will lose electron and the oxidation will take place. Two such chlorine will combine to form here Cl2 gas. It means the chlorine gas will be liberated here. Getting me? Everyone, getting me? And now at cathode, sodium ion will be attracted. It will gain electron here, become sodium here. It means here the sodium will be deposited. So what we have got is, we have got some chemical change by passing the current. This change will take place until we are providing the current, and that is why we say it is a non-spontaneous reaction. The process will continue until or unless I am providing current. And I'm passing a direct current. I'm not using the AC current, but the DC current. You know the difference? You know the difference between DC and AC? Everyone? This is called as electrolytic cell. Direct current from external source into the solution is called as the electrolytic cell. Electrochemical cell in which non-spontaneous reaction takes place by passing direct current from external source into the solution. So some products are formed at cathode and anode here. That device is called as the electrolytic cell. Any doubt here till now? No doubt? Good. So that is what I have already explained. Just go through it. Just go through it. Anion is attracted towards anode, cation attracted towards cathode. Why reverse anode and cathode? Okay. Actually, by this sign convention, anode is positive and cathode is negative. Yes, understand here. Very important. By the sign convention of the signs in the physics and chemistry both, when we pass the current, Cathode is positive, anode is negative. This is correctly given here. But in the electrochemical cell, it is reverse. Now question arises, why reverse? In that case, anode takes place where the oxidation takes place. It's a source of electron. Anode is a source of electron in a electrochemical cell. So that is a negative. Getting me? You'll see that diagram. Please see to it and you will get it. And now, see here, reduction potential of silver sodium is given minus 0.27 and chlorine is given 1.27. And if you find the reduction of the cathode minus anode, that is coming out of a negative value. Negative value means the reaction will not take place at all, or we can say it can be made spontaneous if you provide external battery greater than this value. If you provide external battery greater than this value, then only it will be working, otherwise it will not be working. Are you getting me? Everyone, these two values I have got it. These two values I have got it from the electrochemical cell, right? Electrochemical series. And now, if I find the E naught cell is equal to E naught of the cathode minus E naught of the anode. At the cathode, it is the, what is happening at the cathode? Sodium. So reduction potential sodium minus reduction potential of the chlorine. This value is negative 2.71 minus 1.36. If you solve this, that is coming out to be a negative value of 0.47. It means this cell should not be working. To make it working, we have to provide external battery source then greater than this value. Then only cell will be working. Am I clear? No. I'll be discussing this electrolytic cell in two different aspects here. One, what will the product formed here? And second is the how much it is the product formed here. In the beginning, I think, yes, you asked me how to determine the product formed at the cathode and anode, right? I think, yes, you were there or Anirudh was there, who asked me the question that how to decide what product will be formed at cathode and anode, right? So basically, when you pass current to a cell and some electrical energy converts the chemicals into some other products, that phenomena is called as the electrolysis, right? So basically, electrolysis is the passage of current. It will be good if you noted down this definition of electrolysis. It's very important here. Passage of current in molten or aqueous electrolyte. Molten or aqueous electrolyte. That accompanied by oxidation and reduction at cathode and anode. At cathode and anode. So that phenomena is called as electrolysis, right? So I'm not discussing here those factors which will influence what product will be formed at cathode and anode. So factors affecting product formation. Before I proceed ahead, please let me know what is meant by the word here, electrolyte. What is electrolyte? What is electrolyte? No. No, Yash. Anybody else? So write down what is electrolyte. The substance which does not conduct electricity. Write down the definition, very important here. Electrolyte is a substance which does not conduct electricity in solid state, but conducts in molten or aqueous state. Can you tell me what is the meaning of the molten or aqueous? Difference between molten and aqueous? Fused state and the molten state. Yes, very good. Yes, perfect. If you're melting it, it is the molten. Very good, Neha. And aqueous means when dissolved in water. Aqueous means when dissolved in water, right? So electrolyte is a substance which does not conduct electricity in the solid state, but conducts in the molten or in aqueous state. That is called as the electrolyte. So understand here, suppose I have a sodium chloride here and I'm passing current. Will it conduct electricity? Suppose I have put up here a voltmeter or galvanometer. It will not show any conductance. But in the same sodium chloride, if I have melted it and it gets converted into ions, will it conduct electricity? Yes or no? Yes. So that is electrolyte, the substance which does not conduct electricity in this solid state, but conduct in the molten or an aqueous state. That is called as electrolyte. So first of all, I am now discussing here what is electrolyte. Very important here. And these electrolytes are of two types. Before I go to the electrolysis in detail, we need to discuss about what is meant by the electrolyte here. This electrolyte is of two types here. One is strong electrolyte and second is the weak electrolyte. Strong and weak electrolyte. Can you tell me difference between the two? Difference between the weak and strong? Yes, please, to let me know. No. No, yes. Strong electrolyte is the one which undergo complete dissociation into their ions. And the weak electrolyte is the one which do not undergo complete dissociation into their ions. Strong electrolyte is the one which undergo complete dissociation into their ions, and weak electrolyte is the one which undergo incomplete dissociation into their ions. Getting me? Everyone getting me? Yes or no? Okay. Can you give me an example of a strong electrolyte? Can you give me any example of strong electrolyte? Very good. Any ionic compound, very important. Not only NaCl, it can be MgCl2, it can be sodium sulfate, any ionic compound, right? Inorganic compound. And can you give an example of a weak electrolyte here? Very good, very good. Alcohol, carboxylic acid, they do not undergo complete dissociation into their ions, right? RO negative, H positive, and this is the RCOO negative and H positive. Are you getting me? Okay, yes. Why this happens that certain compound undergo complete dissociation and certain do not undergo complete dissociation, right? It all depends upon the nature of the compound and based upon a degree of dissociation. We call it a degree of dissociation. To what extent it will dissociate, it all depend upon the interaction between the positive and negative ion here. In the ionic compound, there is a lattice energy that is to be broken, and water provides lattice hydration energy. But in case of the carboxylic acid or the alcohol, there is a covalent bond. Can you tell me which bond is easy to break, ionic bond or the covalent bond? Yes, yes. Let me know. No, Srija, no. Ionic bond is easy to break. They are that energy we provide by the hydration energy that breaks the lattice. But to break up this O and H bond, polar covalent bond, this bond is to be broken. For that, we require comparatively higher energy, and that is why they are undergoing incomplete dissociation. They are not undergoing complete dissociation, but they are undergoing incomplete dissociation. Clear? Now, those factors, ionic bonds are of course they are strong, but that is broken by the hydration energy we provide. But in case of covalent bond, water cannot break up the covalent bond so easily because water is polar and covalent bond has some non-polarity. Non-polarity, so it does not undergo complete dissociation. Right? Yes, you are right here, but ionic bonds are cleaved due to the hydration energy that compensates the lattice energy. Right. Now, come to this point now. Next is the basically we're discussing here those factors which affect the product formation of cathode and anode. Number one factor is nature of electrolyte. In this nature, we will discuss about whether it is a molten or aqueous, then what product are formed. Second, it depends upon nature of electrode. Here in this topic, we will discuss about whether the electrode is reactive or non-reactive. Third factor is concentration of electrolyte. In this topic, we'll discuss about if the solution is a dilute or it is a concentrated, then how the product will be affected. Fourthly, we'll discuss about the current density. The products are formed different at low current density and at high current density. And fifth is the use of same metal electrode as that is present in the solution. So all these factors will collectively decide whether which product will be formed at cathode and anode. Getting me? These are topics that we will be covering next time now. That is nature of electrolyte, how it is going to affect the product formation at the cathode and the anode. All these factors we will discuss next time, right?